Geometry is concerned with properties of space that are related with shape and size, which include the notion of point, line, length, distance, angle, surface, and curve. In this study, we use Songket as our object for traditional art material in our culture that meets the geometrical shape and concept that we already learned in class. Kain Songket is a hand-woven traditional Malay fabric with gold and silver thread and worn mainly during official functions and ceremonies. Woven on a Malay frame loom, elaborate patterns are created by introducing extra gold or silver weft thread with the use of a flat needle or cubit. The Songket goes through 8 stages before it becomes a piece of fabric, and it is still traditionally woven. Historically, Songket is worn by royalty and their families. However, today it is mostly worn as traditional Malay ceremonial apparel during royal installation, wedding, birth of a child, and circumcision ceremonies, Malay festive occasion, and formal state function. Recently, Songket have also been transformed into apparel, fashion accessories such as handbags, as well as home products such as placemats, cushion, table runner, and gift items. The use of Songket to decorate the curve and collar of Malaysia Airlines MAS steward jacket is an example of incorporating Songket into apparel. According to historical record, Songket is often associated with the Srivijaya Empire as the origin of the Songket tradition. Several types of popular Songket cannot be separated from locations that were once under Srivijaya rule. One of the dominant locations, which is also believed to be the capital of the Srivijaya Empire in the past, namely Palembang, which located in South Sumatra, Indonesia. Besides Palembang, several areas in Sumatra are also the best-in-class Songket producing locations, which include areas in Minangkabau or West Sumatra, such as Pandai Sike, Silongkang, Kota Gadang, and Padang. Outside of Sumatra, Songket is also produced by regions such as Bali, Lombok, Sambas, Sumba, Makassar, and Sulawesi. Kain Songket refer to Malay traditional clothing, particularly for female. Kain Songket fabric is most commonly used as a sarong that may be matched with baju kurung. However, Kain Songket is available for both men and women. The various parts of a Songket are as follows. For men, stanjak, long sleeve shirt, bengkung, samping, and pants. For women, long sleeve blouse, selendang, and sarung.
Next, we move to the size. By using measurement tape, this kind Songket have length 80.4 cm and width 91.3 cm. But since the kind Songket have two combined layers, thus the width is 182.6 cm, which is the area of region is 14,681.04 cm square. To measure the object, we place the kind Songket on a flat surface. We only took the measurement values of the length and width of the kind Songket without opening the thread stitches that connected the two ends of the fabric. This means that we only take half of the actual length of the fabric to make it easier for us to relate it with the geometric concept study. The measurements are repeated 3 times to get more accurate value of length and width. The main reason that there are 3 different measurement values for length and width is because of the condition of the fabric, which is easily expand, causing error values that occur during the measurement process. As you can see, here is the table of type of measurement, first, second, and third measurement. Hence, we just take for the average of measurement. Here is the diagram, front of kind Songket and back of kind Songket. We can see here the length of kind Songket we take is 80.4 cm, while the width is 91.3 cm. There is many geometric shapes in this object, and significantly are rectangles for each line at the region of surface of kind Songket. Others we can see rhombus, kite, and 2 types of triangle, which is isosceles triangle and right angle triangle, when we focus on each different pattern that has on the kind Songket. Next, I'm gonna explain about the geometrical shapes. First is rhombus. The characteristic in a rhombus is all sides of rhombus are congruent, opposite sides are parallel, opposite angles are congruent, the diagonals are perpendicular and bisect each other. Consecutive angles of rhombus are supplementary. Second, our kind Songket have kite shape. Kite has 2 pairs of adjacent equal sides. A pair of opposite angles of kite is congruent. Diagonals are perpendicular. Vertex angle are bisected by diagonal, and the diagonal between non-vertex angle of chi is bisected by another diagonal. Third is rectangle. A rectangle is parallelogram that has a right angle. All angles in triangle are right angles, and the diagonal of rectangle are congruent. Next, we have two types of triangle in our kind Songket, which is isosceles triangle and right angle triangle. For the isosceles triangle, the characteristic is two sides of equal length are the legs. The third side is the base, while the point at which the two legs meet is the vertex of the triangle, and the angle formed by the legs is the vertex, and the two remaining angles are the base angle and equal. Another one triangle is right angle triangle. The acute angles of a right triangle is complementary. One angle between the base and altitude is the right angle, and the hypotenuse is the longest side.
Today, I'm going to explain a bit more about the thing that we use in our assignment, which is kain Songket Terengganu Melayu Tradisional. I will focus on the geometrical concepts for our kain Songket. The first shape that I will explain is rhombus. The rhombus shapes are used to make the motif of the kain Songket. Rhombus is a closed two-dimensional plane figure. It is classified as a spatial parallelogram, and because of its distinctive properties, it is designated as a quadrilateral. Rhombus are also known as equilateral quadrilateral because all of their sides are the same length. Based on corollary 4.3.1, all sides of a rhombus are congruent. Thus, the length of the rhombus for each side is 1.5 cm. Each rhombus motif from the kain Songket has vertical diagonal of AC that is connected with vertex A and C, which is 2 cm, and a horizontal diagonal of BD that is connected with vertex B and vertex D, which is 2.5 cm. Hence, the perimeter of the rhombus where P equals to 4 times A. A is represented as side of the rhombus. Then, each side's length is 1.5 cm. So, 1.5 cm multiplied 4 equals to 6 cm. Thus, the perimeter of the rhombus is 6 cm. Next, we calculate the area of the rhombus. We are going to use the formula of A equals to diagonal of AC multiplied diagonal of BD divided by 2. And we obtain that the area is 2.5 cm squared. The second shape is isosceles triangle. It is defined as triangle with two sides of equal length, two equal angles, three edges, three vertices, and the sum of internal angles of a triangle equals to 180 degrees. Two sides are congruent to each other, and the third side of an isosceles triangle, which is unequal to the other side, is called as the base of the isosceles triangle. The two angles opposite to the equal side are congruent to each other. It means that it has two congruent base angles. Thus, the angle which is not congruent to the other two congruent base angle is called as an apex angle. Each of the base angle is 70 degrees, while the apex angle is 40 degrees. Each of leg's length is 7.5 cm, and the base length is 3.5 cm. To calculate the altitude length of the isosceles triangle, we have to apply the Pythagorean theorem, which is altitude squared equals to hypotenuse squared minus radius squared, and we get the answer 7.29 cm for the altitude length. Hence, to find the area of the isosceles triangle, we have to apply the formula of A equals B times H divided by 2, which is B is represented as base and H is represented as height of the isosceles triangle. And we got the area equals to 12.76 cm squared. Next, the perimeter of the isosceles triangle is the sum of all three sides. Thus, the perimeter of the isosceles triangle is 7.5 cm plus 3.5 cm plus 7.5 cm equals to 18.5 cm. The third shape is right angle triangle. A right angle triangle is a triangle that has one of its interior angles equals to 90 degrees. The sum of all the interior angles is equal to 180 degrees. The other two sides adjacent to the right angle are called as base and leg or altitude. Thus, the longer side is called as hypotenuse. The three sides of the right angle are related to each other. This relationship is explained by Pythagorean theorem. According to this theorem for right angle, hypotenuse squared equals to leg squared plus base squared. area of a right angle is calculated using formula A equals to B times A divided by 2, where B is the base of the right angle triangle and A is the leg of right angle triangle. Hence, the area of a right angle triangle is A equals to 1.5 cm multiplied 2 cm divided by 2, and we will have the area equals to 1.5 cm squared. Next, the perimeter of right angle triangle is sum up of all its sides. Hence, to find the perimeter of the right angle triangle, we need to identify the length of the hypotenuse itself first. Thus, we substitute the value of the leg and the base into the Pythagorean theorem. And we obtain that the hypotenuse length is equals to 2.5 cm. So we calculate the perimeter 2 cm plus 2.5 cm plus 1.5 cm equals to 6 cm.
2.3 Transformation in motif and patterns. There are several concepts of transformation that exist in the motif and pattern of this kain Songket Melayu traditional. There are 3 patterns that will be discussed in this section. Each of these patterns will have several motifs and that found on this object. Each of the motifs will be related to the concept of transformation, which is translation, rotation, reflection, and also dilation. Pattern 1. There are 2 motifs that we found in this pattern. Firstly is motif Kelarai 4 Sebilik. This motif exists in this kain Songket Melayu traditional. It shows the symmetrical design through the process of symmetry produced in Songket weaving. The translation process displays the object being on a basic unit of repetition in a linear plane of symmetry. The object moves the entire image at a fixed distance in a fixed direction. Second motif is Pucuk Rebung, which is in Isosceles Triangle. The concept of reflection is found in this motif. This forming was done by making the initial pattern then reflected on the y-axis. Pattern 2. There are 2 motifs that can be seen in this pattern. Firstly is Kelarai Kepala Lalat. The concept of reflection is found in this kain Songket Melayu traditional. The rhombus shape weaving are identified in this object. Rhombus shape, which is known as motif of this object, reflected on the reflection axis, which is slanted, and produce another image of rhombus motif without changing the original shape. Motif 2 is Ninjan. It can be seen that the dilation concept is found in one of these motifs. The dilation concept can be seen with the same image but with different size, which is black and grey color.
As for the summary, from the chosen object for this investigation, which is kain Songket, we know that this traditional art is what we use not just for formal activities or events but also in our daily life as our clothes or more. The design of kain Songket is unique and varies with many elements, especially geometrical elements. Every element or motif in Songket has its own meaning and is based on nature and geometrical shapes. After further investigation, we have found many geometrical shapes in this Songket. Most of the motifs consist of geometrical shapes such as rhombus, rectangle, kite, isosceles triangle, and right angle triangle. Most of the shapes that appear in the Songket are rectangle and rhombus. You can spot the isosceles triangle at the top and bottom of the kain Songket and right angle triangle around the rhombus shapes. As for conclusion, from this task, we can see how important geometry is in our life. This task has taught students to get to know more about geometry by trying to find and recognize the geometrical shape, whether it is hidden or not in the traditional object that we have chosen, which is, in this case, our kain Songket. It cannot be denied that in Malaysian traditional arts, geometry concepts have been used widely. The relationship between Malaysian traditional arts and geometrical concept is very strong. Many arts, especially Songket, have a geometrical shape as the design for the material, and it is unique from each other as this is a handicraft. Therefore, we can conclude that kain Songket is one of the Malay's traditional art that strongly uses geometry as the base of its design.